dispersion of the dataset is measured to find out how spread out or close to the data values are. So, it measures how the various elements behave with regards to central tendency. It includes range, interquartile range, absolute deviation, variance, and standard deviation. It is also known as the measures of spread or measures of variability. So, let's go to the range. So, given the data set, we have 7, 10, 9, 14, 16, and 20. So, we must find the highest value and the lowest value. So, the highest value we have 20 and the lowest we have 7. So, the formula of the range we have R equals highest value minus lowest value. So, we have to substitute the given values. We have 20 minus 7 equals to 13. So the range now we have 13. So the value is 13 tells that the highest value and the lowest value is 13 steps away from each other. Also with the distance 13, all the values of the sample is contained. So we are now in interquartile. Interquartile is also called the mid-spread. It is the difference between the 75th and the 25th percentile or between upper and lower quartile. So we have the given data set here. The 6, 7, 10, 11, 12, 13, and 17. So if we find the Q1, the first interquartile, we have the formula here. Where M is the location, the N is the number of samples. So we have 1, 2, 3, 4, 5, 6, 7. 7 number of samples. So we must substitute the 1 plus 7 plus 1 over 4. Why 4? It's because from the word quartile, we are going to divide 4. So we're going to calculate this. It's 8 over 4 is equals to 2. So the first quartile is in the second. So the Q1 is first, second. So the Q1 is the 7. So we're down to the Q3. So 3 times 7 plus 1 over 4. So we are going to calculate. So we find the sixth number. First, second, third, fourth, fifth, and the sixth is the 13. So Q3 is the 13. Find the interquartile I2R. We subtract the Q3 and the Q1. So our Q1 is 7 and our Q3 is 13. So we're going to substitute 13 minus 7 is equals to 6. So our IQR is 6. We're now in variance. This is the expectation of the squared deviation of a random variable from its mean. It is measure how far a set of numbers are spread out from their average value. So given the data set, we have 13, 12, 14, and 17. So we're going to arrange it from lowest to highest. So 12, 13, 14, and 17. We must find the number of samples. So the number of samples is 1, 2, 3, 4. So the number of samples is 4. So to find the mean, we must add all the samples divided by the number of samples. So if we add this all, it is 56. Divided by 4, we have 14. here in x minus mean, we're going to subtract each number of samples to the mean. So 12 minus 14 is negative 2. Then 13 minus 14 is negative 1. 14 minus 14 is 0. And 17 minus 14 is 3. So the next is we're going to square the x minus mean. So negative 2 squared is positive 4. Then here we have positive 1, 0, and then 3 squared we have 9. So to find the variance, we sum it all. It is equal to 14. So using this formula, squared is equal to 14 divided by 4 minus 1 equals to 4.6. So to find the standard deviation, it is from the square root of its variance. So t squared is 5 because our variance is 5. So the square root of 5 is 2.24. So this is the standard deviation. So lastly, we have the absolute deviation, where the formula is summation of absolute value x minus mean over n, where n is the number of samples. So given the data set, 13, 12, 14, and 17. So we're going to arrange it again from lowest to highest. So we have 12, 13, 14, and 17. So the number of samples is 4, and the mean is 14, same as from the variance. So to find the absolute value of x minus mean, we're going to subtract each sample from the mean. So 12 minus 14 is negative 2. So since it is absolute value, it will always be positive. So it is positive 2. Next is 13 minus 14 is negative 5. Then it is positive 1. So 14 minus 14 is 0. Then 17 minus 14 is 3. So to get the absolute value of x minus mean, we're going to subtract each sample from the mean. So 12 minus 14 is negative 2. Since it is absolute value, it will always be positive. So 13 minus 14, we have 1. 14 minus 14, 0. And 17 minus 14, we have 3. So we add it all. We have 6. So to get the absolute deviation, we're going to follow this formula. So AB is equals to 6 over 4, where n is the number of samples. So 6 divided by 4 is equals to 1.5. So AB is 1.5. This is the absolute deviation. So I hope guys you have learned a lot about the measures of dispersion.